Imagine a moment so extreme that it cannot be measured by clocks, recorded by observers, or fully described by physics. A moment beyond every apocalypse ever imagined. A moment when reality itself disappears forever. Not a destruction of planets, stars, or galaxies, but the complete loss of the framework that allows existence to exist in the first place. This is the final moment before reality disappears forever, a boundary where the universe reaches the ultimate limit of its existence. For billions of years, the universe has appeared stable. Galaxies have formed, stars have burned, planets have orbited, and life has emerged. The laws of physics seem permanent and reliable. Gravity pulls matter together. Electromagnetism binds atoms. Quantum mechanics governs the smallest particles in existence. These forces create the order that makes reality possible. Yet modern physics suggests that this stability may be temporary. Everything that exists depends on a delicate balance. If that balance is ever broken, reality itself may begin to unravel. The universe is not guaranteed to last forever. In fact, some theories suggest that existence may already be living on borrowed time. One of the most disturbing ideas in modern cosmology is vacuum decay. According to quantum field theory, the universe may not occupy its true lowest energy state. Instead, reality may currently exist in what scientists call a false vacuum, a temporary condition that appears stable but is actually vulnerable to collapse. Imagine a ball resting in a shallow valley. It seems secure, but somewhere nearby exists a deeper valley. If the ball ever falls into that lower state, everything changes instantly. The same may be true for the universe itself. At any moment, somewhere in space, a tiny quantum fluctuation could trigger a transition into a lower energy vacuum. The result would be a bubble of altered reality expanding outward at the speed of light. Inside that bubble, the laws of physics would be completely different. Atoms might no longer exist. Matter might instantly dissolve. Stars could vanish. Chemistry could become impossible. Life would be erased without warning. The terrifying aspect is that nobody would ever see it coming. Because the bubble expands at light speed, its arrival would be simultaneous with its effects. There would be no signal, no alarm, and no opportunity to react. One moment the universe would appear completely normal. The next moment reality would be gone. But vacuum decay is only one possibility. Another possibility emerges from the long-term evolution of the cosmos itself. The universe has been expanding for nearly 14 billion years. More importantly, that expansion is accelerating. Galaxies are moving farther apart. Empty space continues to grow. The larger the universe becomes, the colder and more isolated everything appears. Over unimaginable spans of time, stars exhaust their nuclear fuel. The brilliant lights that fill the night sky today eventually burn out. New stars become increasingly rare. Entire galaxies grow dark. After trillions of years, the age of stars comes to an end. What remains are stellar remnants, white dwarfs, neutron stars, and black holes drifting through an increasingly empty universe. Yet, even black holes are not eternal. According to the theory proposed by Stephen Hawking, black holes slowly evaporate through a process known as Hawking radiation, over timescales so vast they dwarf human comprehension. Even the largest black holes eventually disappear. When the final black hole evaporates, the universe enters an era of almost complete emptiness. No stars, no planets, no galaxies, only scattered particles and faint radiation moving through endless darkness. At first glance, this may seem like the end, but according to some physicists, reality can become even stranger. As entropy continues increasing, the universe approaches maximum disorder. Energy becomes evenly distributed across all of space. No gradients remain. No useful work can occur. Nothing changes because change itself requires differences in energy. The cosmos becomes trapped in a state known as heat death. Time continues to pass, but nothing meaningful happens. No structures form. No information is processed. No complexity emerges. Reality still exists, but it has effectively become frozen. Some researchers argue that this state represents the practical death of the universe. Yet there are theories suggesting an even deeper ending. Some models predict that dark energy may grow stronger over time. If this occurs, the expansion of the universe could accelerate without limit. Eventually, the force driving expansion would overwhelm gravity, electromagnetism, and even the nuclear forces holding atoms together. Galaxies would be torn apart. Solar systems would disintegrate. Planets would shatter. Atoms themselves would be ripped into fundamental particles. This scenario is known as the Big Rip. In the final moments of a big rich universe, space expands faster than the forces capable of maintaining structure. Reality loses coherence at every scale simultaneously. The universe does not merely end. It is pulled apart from the inside. Every connection that defines existence is severed. Every structure disappears. Every law that once created stability becomes powerless. And then comes the final moment, the last possible instant before reality disappears forever. A moment where space loses meaning. A moment where time can no longer flow. A moment where matter no longer exists. A moment where the universe crosses a boundary from which no return is possible. Beyond that boundary may lie nothing. No stars, no darkness, no emptiness. Not even the concept of existence itself, because when reality disappears forever, there may be nothing left capable of describing what remains. The universe simply reaches its final limit, and for the first time since the beginning of time, existence itself comes to an end.